no, two more sessions, and then we're finished for today. Jira, I skipped Jira in the session about Scrum and all this. So I'll take that now. Anybody of you familiar with Jira? Yes, some of you. I have to admit, I use Jira here on HIG, but we're not using Jira on our development company. Then we use another tool for these kind of things, issue tracking and so on. So, but I'll try as good as I can to walk you through it so that you get a basic feeling of how to use Jira as well. Yeah. Okay. In the Jira server that is set up here, there are several projects, and the projects that we will set up in this course, we will add to Jira as we have assembled the teams. Okay. Then we will register new projects, and we will add you as users to those projects. So for now, we can look at some of the projects that were done last year to get some feeling about how we use Jira. Okay, for example, SQL Decomposer. Okay. Is this large enough?
Yeah.
Yeah? Were you at the back as well? Yeah. Okay. In Jira, you have on the top menu there, you can browse your projects, you can browse your issues, and you can go to the Agile board, you see here, on the Agile menu to see, for example, if you have set up Scrum board or Kanban board, you have them there. And if you know any shortcuts that are more convenient than those I go now along the paths and the shortcuts that are more convenient than those I use, just raise your hands and tell us, okay? But here we have our issues. We can also browse the issues from this menu item. But now I chose the project, and it automatically chooses the issues. We can either see all the issues that are put into the projects, or we can look at specific issues, whether or not they have some kind of state or something like that. So we can filter them in many different ways. For example, type all that are bugs, or all that have status to do, to pick new issues to put into your sprint backlog.
This is more of like a inside of the team communication.
Yeah, exactly. So the development team typically uses Jira to manage issues and tasks. And you remember we talked about product backlog. All the issues that we set up in Jira is effectively our product backlog. And those that we assign to one sprint is then a part of the sprint backlog. Okay? So here we have all the issues. We can look into one of the issues. Yeah, it's the one that's open here. You see that it's a type bug. Bug is identified. Priority major. You remember the priorities. Let's look at the priorities that we get in Jira. Blocker, critical, minor, and trivial. And major, of course. And whether or not it's resoluted or not. It's unresolved for now. So no one has picked this because it's a to-do status on it. Okay, we can look at those in progress. I suppose nobody's in progress here. Yeah. No. So they have finished all the tasks in this project. So you can filter all the issues from this GUI. You can also filter on who it's assigned for, so you can look at all the issues that you have taken responsibility for, or that has been assigned to you. Yeah, and so on. You also have a left menu here with my open issues, reported by me, etc. It's quite basic. It's more important to remember the terms, issue and sprint and backlog. And there are a lot of documentation of Jira on the web, so those are available also. I will show you some more things. For example, how to look at your Agile board. You can choose Agile in the main menu. And now I chose the SQL Decomposer project. Here we can look at the burn down chart. For example, the burn down chart for sprint 1. Let's analyze this burn down chart. It's not perfect. So I suppose they were getting familiar with estimation in Jira and so on. And the burn down chart for sprint 3, I think that is a little bit prettier. Yeah, you see in Jira you have both the graph for how many tasks you have left or how many working hours you have left. That's the one going down. And the one going up is how much time you have spent on doing those tasks. So if it's in a perfect world, this graph should end up as high as you have estimated when you started the sprint. You see. And this is then, of course, the ideal graph of how the work should progress during that sprint. You see? Let me So if you log your issues, register one issue and estimate it correctly, put it into the sprint backlog correctly, then you will get the correct burn down charts according to how much time you have spent and how much time you estimated on that sprint. Okay? You can also get different reports here, sprint reports for example, where you get the actual burn down chart and you see the completed issues. This is quite convenient if you have if you release your software in versions. Like have you heard about SEMVer? Semantic versioning. Yeah, how to name your versions of your software. Then you have minor releases, which is 1.1, for example, and major releases, which is 2.0. And so the first number is major releases. Then you have minor releases, and the last is hotfixes or patch releases. So then you have a summary of what you have done for this release. So you can put that out to document it for your clients. So these reports are quite convenient. Yeah, you can get actual version reports as well. Let's go to the project. Let's say that I want to create a new issue here. We're building our product backlog. Well, that should be one of the first things you're doing. Build your product backlog based on the user stories that you get from the product backlog. Okay, then I register new issues, and I have a create button here in the main menu. So here I create my issues. I assign them to a project. The type of the issue, we talked about that. Typically a little summary of what we're going to do. If it's correlates exactly with the user story, maybe you can use the user story. Priority of the issue, so that you know what to prioritize when you plan your sprints. Due date when it's due, that depends on what sprint it's put into. And so on and so on. So I have a lot of properties here. And if you go further down here, we have estimates. So this is the actual working hours that you think you're going to use on that issue. If it's a large issue, you typically also update the remaining estimates, maybe after the working days is done or something. What happens a lot of times is that you estimate it for 5 hours, and when you finish with it, you just move it to done instead of setting 0 for remaining estimates. Yes, and what sprint it's assigned to. So when you're planning your sprints, you should go into each issue that you want to put into the sprint backlog and register it for the sprint that it's going to be done in. Okay?
That happens when you assign it to the sprints.
Yeah.
So you don't need to edit each of them.
No. If you assign it here, yeah.
Yeah, that means you created the issue whilst the split was going on while you're starting the split.
Sorry, what do you mean?
That means you created the issue at the beginning or in the middle of the split.
Yeah, if you're assigning it here, yeah, I agree. So typically you build your product backlog without setting the sprint here. But when you edit the issue when you're planning your sprint, then you set it for that sprint.
Well, when a bug occurs during a sprint, are we supposed to add that to the current sprint or in the backlog for next sprint?
The issue that you're creating, that should be in your product backlog. That means that you don't put any sprint, you don't set this field when you create it. You set it when you're having your sprint planning meeting. Then you set it to the sprint that you're going into. See? Then you will get the correct estimation in your burnout chart. Yeah. Have you heard about story points? Somewhere? It's a way of estimation as well. Instead of using working hours, you're using story points. So each is typically related to user stories. You set how many instead of hours you're using another measurement that's called story points. It's used in planning poker, I think, for example. Yes. Anything else that is reasonable to show for you that have used you a lot? Oh yeah, the Scrum boards, of course. We need the Scrum boards. We go to Agile, SQL Decomposer. because now I have activated the report button, you see? So now I am in report mode. You can also be in plan mode to see the backlog, the entire backlog, and the Scrum backlog, and you can look at work. On the work button, you get the actual Scrum or Kanban board. Okay, this is. And here we see the states of issues: to do, in progress, ready for review, and done. So if you make a new issue now, and you're planning your sprint, you're assigning it to this sprint, you will have a list of to-dos here, tasks, and you just drag them over to in progress whenever you're starting on an issue. You see? And then when you are done with the implementation and want someone else to review it, you can drag it over to ready for review, and then we're done. And if you use this correctly, you will also get the correct burn down charge and the correct estimation and the correct time spent on your project.
What here do you mean by review state?
Have you heard about peer review?
Yeah,
Yeah.
I know, but it is the same. So we will review code of each other, or yes.
Either review code if it's something related to GUI, maybe others would review it in some other way as well.
Okay.
Yeah. But yeah, so typically you have another. If it's code, you have another developer to review what you have done, and or you have a lead developer. Typically in a Scrum team, you don't have lead developers, but if you have that, they review what you have done, if it's according to maybe some standards that you're following, JavaScript standards or Java standards or something like that, coding standards, etc. And if you're using the APIs and SDKs and etc. correctly, according to what the company wants you to. So that's typically a review. It's quite useful actually. Yes. So that's a quick jump into Jira. Try to get to know it as soon as you get access to Jira. Try to create issues and try to see what kind of what you can do with issues in Jira. And as soon as your team starts up, you should be able to manage Jira accordingly to what you need in this project.
Will they be given username and password for Jira, or will we just use our student ID and password as using prompter?
I'll come back to that in the mail that I'm writing in the start of next week. Okay. Last year we set up all the accounts manually. So that was. But many of you have accounts, did you? Yeah, some of you. Yeah. So probably we'll do that, but I know there are LDAP integrations and so on, so we'll see. Maybe IT can fix something there. Yes. That was Jira. Let's go on to DVCS and Git. One more time. How many have used Git here?
What?
Git, used Git, yeah, version? Yeah, everybody. Nice. So then I maybe skip the basics then and go on to other stuff. No, we'll go through everything, but I won't dwell on the basics then. Okay. Have any of you heard about Git flow then? Yeah, a little bit. Yeah. Yes, we'll come back to that as well. It's one way of doing branching, and I'll show you. DVCS. So what's that, DVCS?
This way we wash control system.
Yeah, exactly. So that's 1 point for you. Topics we'll look into VCS, SCM, early systems, DVCS. VCS terminology, Git and Git flow we'll look into, and distributed Git services. And if you're familiar with Git, this won't be any. It will be the basics, but I'll also show you a tool set which is called Git flow, the basics of that, and I can do some live Git flow stuff as well as to show you how to use it in command line. Who's using the command line for Git? Some of you, and some GUI. Who's using GUIs? Yeah. Okay. So I suppose that you're familiar with a lot of the terms that I'm going to talk about. What is version control? Code changes, bug fixes, new features, new implementations, new versions, etc. And mistakes are made and developers often need to track back. DVCS, Distributed Version Control Systems, or SCM, Source Control Management. Both terms closely related to revision control in software engineering. So the main thing here is that we want revisions of our code. We want versions of our code. We want to track back at any time to any implementation that we have done. Distributed VCS do not rely on a centralized server. Local repositories contain all revision data, and the repositories are cloned from external sources. Examples of distributed VCS?
How is it distributed?
No, one example. Do you have any examples of the VCS? Yeah, exactly. Git, that's a distributed VCS.
It's Mercurial
Yeah.
distributed.
Yes. Anybody using that? Yeah,
In my work.
exactly. How are your experiences with that?
It's much easier than Git.
The tools or?
Not only the tool, but the semantic. Also, because Git's somewhat more extendable, I don't know. There are a lot of things that much easier can be done in Mercurial, but Git, I think, is more flexible in this way.
Yes. Git. It's a unique branching model. Git allows and encourages you to have multiple local branches that can be entirely independent of each other. And what's a branch? Yeah.
It's kind of a pathway, like you can sort of say that this, now I want to make like a path for the release 1.0, and I can like push my commits to that release instead of to, for example, another branch, since for each commit you like extend for some kind of tree or some path. And when you have different branches, you have different paths, sort of.
Yeah. So it's a new path in your revision history.
Yes.
And then you can have new revisions in that path. And then that's effectively a branch. And how do we do branching in Git? Do you remember that?
Git branch.
Yeah, exactly. Nothing more, nothing less. This means that you have frictionless context switching. And you can have role-based code lines, feature-based workflow and disposable experimentation. Because if you, whenever you're branching out something, you can dispose that at any time, but you still have your other branch. Let's say that you have a master branch and you branch out to a develop branch or some kind of feature branch. You can dispose all that's done in the feature branch without disposing the master branch. You still have your revision history in the master branch. Okay, terminology. A repository. That's typically the container of the project or the project's folder. You can call it many things. And a branch, parallel version of a repository. Also a new path for the revision history. A remote, the version of something hosted on a server. Local clones are connected to the remote. Or you typically say that a local clone is tracking a remote. And clone, that's a copy of a repository connected to the remote version. Commit. One commit is a revision. So if you write some code, you do a commit, then you have one version of your code, one revision. Then you write some more code, do another commit, then you have another version. You can rebase your Git branches and go back to your previous commit and then have the code that you had in the previous commit. So these are revisions. States in your code, you can say. Diff. That's the difference between two commits. You can look at what you have written now without doing a commit and do a git diff, and you see what's the difference between the code as it's in your project folder now and the last commit. Then you see the differences in the specific files. You do a git fetch, you get the latest change from a remote repository. A remote repository can be, for example, GitHub, which is a Git server, or a self-hosted Git server, or something like that. Merge, then changes from one branch is applied to another. What it actually does if you branch out something and you have some commits in that branch, you say that you merge it into, let's say this is the master and you have a feature branch there. Then you merge it into master, you will have all the revision history of your feature branch put into master, and it will try to resolve any differences or conflicts with that. You can also merge it in without having all the revision history. I don't remember the actual parameter for that in Git, but there are two ways of doing merging. Sorry?
Cherry commits. Cherry commits. This and this and this.
No, it's not that I'm thinking of.
How do you do it?
Is fast forward or not fast forward? I think.
Fast forward is when there's a language conflicts, is it? I think it is.
Yeah, I don't remember the actual term. You also have distributed Git systems. Have you used GitHub? Yeah, of course you have. Some of you also have used Bitbucket, maybe?
Yes.
And Bitbucket is tightly integrated with the Jira, so that you can actually annotate your commit messages and resolve issues directly with a commit message. So I think you're using hash and the ID of the commit of the issue ID.
Something like that.
Is that correct? Yeah.
Something like that.
Yes. So you can resolve without going into Jira and saying that it's resolved, you can annotate this in your git commit message. So keep that in mind when you're working with Jira. Okay. Git basics. There's a getting started guide to install it here. I suppose everyone has installed it if you have used it. You can either use the command line or some kind of GUI. Git init. That's the initialize a Git project. What happens when you do Git init? What practically happens?
Created folder called .git.
Yeah.
Current folder.
Yeah.
And this folder initializes with Git files needed for Git repository.
Yeah. Some config files and yeah. So let's get in it. Git clone. Let's do clone, for example, an external repository. Git add. What you're doing actually in Git add? Why Git add?
We start tracking files.
Yeah.
Yeah, the change to do.
We're staging them. Yeah. So we're staging files. We're saying that this, and this file should be a part of the next commit, a part of the revision history. So we can either do git add minus large A, then we stage all the new files automatically, or we can do git add and a specific file, and then we stage only that file. So then we're saying that these files should be as well be a part of the next commit, the next revision history. Okay, git commit minus M to put in a commit message, and a commit message, of course. Okay, git flow basics. If you want to read the article that is based, that this branching model is based on, you can go to this link. It's an article by Vincent Dreesen that describes a branching model. How to do branching in Git. Because there are very many different practices for how to do branching in Git in different companies. Some have standards for it and regulations for how to do branching and merging and so on, and others don't. So it's more or less you have a develop branch and you have a master branch and work with it. So, but this standardizes one branching model. Remember that there are other ways to do this, but this is one example of how to do branching in Git. For example, the GitHub flow. GitHub advocates another approach to how you do branching and merging with its GitHub flow. You can look into that, and I'll put out a link on the project handbook so you can read up on that as well. The main thing in the GitHub flow is that rather than doing branching, you clone a repository, fork it, or something like that, and then you do a pull request to the GitHub repo in GitHub, and then someone reviews what you have done in that pull request, and then it's merged into the master branch. So it's a little bit simpler approach to branching than this, but we'll look into this as well. What kind of branching model you agree upon within your team, that's entirely up to you. I have to hurry, I see. But the main thing here, in this model, you have a master branch and you have a develop branch. So whenever you're starting to develop, you're working on your develop branch. Maybe one developer is working on a specific feature of your software. Then you branch out in what's called a feature branch. Okay, so he works on the feature branch. He can publish that out to the GitHub repo, for example, so that others also can work on that feature. But the main thing is that he branches out for that feature. And every other development is happening on the develop branch. And of course, nothing is happening on the master branch. Okay? So now we have developed so many features that we are ready to release something, ready to release a new version, for example. Then we start a new release branch. These are release branches. Maybe we have a version, a release candidate or something like that. We test it with other developers, other users, etc., etc. We are on the release branch, and after some commits, we are ready to launch this version. Okay, it's version 1.0 or 0.2 or something like that. No, it's typically a major version, sorry, if we do a release. Okay, then we merge the release branch to master, and we merge the release branch to develop. Okay, so now we have the same state for version 1.0 on the master as we do on the develop branch. Here another feature is branched out, and that is only merged after this release. Okay. Yeah.
On that last part where you start merging all the different develop branches into one single branch, isn't there really, really high risk for that stuff could really, really go bad at that particular point?
Here, you think? Here?
Yes, and further down as well. Towards the bottom. Yes.
Here. Yes. It's a possibility. So you typically have peer reviews when you do these kind of things. Look at my code. Is it ready to launch? But also, you can merge the develop into your feature branch as well as you go along to test it and check that your feature isn't breaking any other stuff. So you can have mechanisms that assure you in that development process. Yeah. But that's a danger in any kind of merging and branching, branching and merging. Okay. So what happens then if we launch a 1.0 version on the master branch and we see that okay, there's a major bug there on the software that we have out in production. Then we want to do a hotfix. So we have a hotfix branch as well. So we branch that out from the master branch, do some kind of fix that fixes the bug, and then we merge it into master again. And then we use the minor version type of tagging. So we would have 1.1 or 1.4 or something like that. You aren't depending on following these kind of taggings. You can do it accordingly to semantic versioning as well, if you want to do that. So that's the main thing about how you're doing branching in this flow. Okay, let's see. Do you want to see a small demo of it in use? Yes.
So what do flow does exactly?
So I can organize branches, so you're not confused instead of code base.
Yeah.
What's the difference to write git flow and git branch?
I'll come into that when I do this demo. Yeah, cool. No files. Yeah. Now I have a code base here for system. And I do some. Typically, I want to set up Git first. So first I do Git init. Okay. Do you see this? Or do you want larger text? It's good. Initialized an empty Git repository. I'll do this only on a local repository, not on an external one, on a remote. So only local. So Git flow. That's tools built upon Git to make it easier to follow this branching flow that I was this branching model that I was talking about now. Because you saw that there was a lot of branching and merging and stuff that could be quite heavy to do on the command line, for example, with on the Git. So it fixes it gives us a great deal of easy tools to do this. So I do Git flow in it as well. This is to initialize Git flow on this repo. It asks for branch name for production releases, for next release development, and for feature branches, release branches, hotfix branches, support branches, and version tag prefix. I'll just use the standard names here now. Okay, so I'll just use the standards. Okay, and now you see that I'm in the develop branch. You see that on the bottom on the right there. Okay. What I do now, I have changed one of the versions of one of the packages that I use in my software. Okay, then I need to do a new version of that, git add, and I do a git commit. This is the first commit, so I can call it that. Okay, and I want to do one new release with git flow. So then I do git flow release start. Okay, so now I'm starting a new release branch. And I want to call it 1.0, so it's a major release. Then Git flow does all the things that you should have done in Git for us, like Git branch and Git. I don't remember all the things we need to do to get this right, but Git flow does it for us. So it set up a new release branch. It keeps the develop branch, and maybe I bump my version in my config file as well, so that is correct. And I commit a new bumped major version. Commit a new version, and then I can do git flow release finish and the tag number 1.0. And then Git flow will handle the merging to the master branch and the merging to the develop branch and the tagging of the master branch, so you have a version of the master branch. Okay, so Git flow gives you that. And that would have been 4 commands or something like that in Git. It asks for a commit message and a message for the tag. What should the tag be? 1.0. And a merge commit message when you're merging into develop. So I'll just use the standard stuff there. And now you see that I'm in develop, but still the master branch has been updated and the develop branch has been updated with the release 1.0. So now the master branch has that tag on the last commit. And what I typically do then, if I use GitHub or something like that, I do git push, and if it's set up to track the remote, git push tags. What I do then, I push my new code up to GitHub, and I also push all the tags that a Git flow has set. Okay, I won't be able to do any more on this today. If you have any questions, don't hesitate to ask me. There is a great what do you call it? Cheat sheet on the web. Cheat sheet Git flow. Yeah, where it graphically shows you what the actual commands in Git flow is doing. Okay, when you're branching out to features and branching out to releases and so on and so on. But remember, this is one way to do it. The GitHub flow is another way to do it. Within your team, you have to agree upon what kind of branching you want to use. Yes, that was it. Any questions?
The groups. When are we going to form the groups?
I will send out a mail where I inform you with all the details that you need to know. And then I will also write there that you should reply to this mail with your requests for projects. And there you prioritize 2 projects, okay? Yeah, the first project, of course, the project you want to do, and the second priority project as well. So you answer on that mail. But this will be sent to your KIG account. So remember to check that account. Okay? I'll do that as soon as possible. And then we will form the groups and teams, and we will inform you on Confluence on which team you are part of. Yes? Other questions? No? Yeah, 5 minutes overtime. That's okay.
And we will try and arrange a barbecue on Sunday at around 6 p.m. ish. If that's